Good afternoon, everyone. I hope everyone had a good lunch. And today, in the next few minutes, I'm going to discuss with you about deploying responsible AI seamlessly in clinical workflows. I'm a radiologist, previously was a professor, and now moved into AI full time for the last 7 years. And today, basically, one of the important activities or jobs what we do is to see how we could use AI in the clinical workflows in real world. A lot of interesting lectures in the morning, important and deep insights. But when, as AI implementers, when we go to hospitals, the common questions which are asked to us by physicians and administrators typically include some of the following. One or two important aspects they would like to know about AI is this AI fair and without any bias? And this is very important because the training data set for AI varies from different geographies. How this AI was trained becomes a very important question in the minds of users. The second question is typically that is asked is how do we explain the AI output? How did the AI come to a particular conclusion? And then follow on is how do we trust the decisions made by the AI? Finally, when we deploy AI, the questions come around, is there a way in which using AI we can actually reduce the number of people required to assign the cases manually to an expert? But typically, the expectation is when we deploy AI, everything happens automated. That doesn't happen all the way. Someone actually have to push that particular study to the AI model for inferencing. And again, there is a cost in terms of pushing the study and also the time involved. And finally, how do we leverage hospitals' data for creating new AI solutions? AI developers make applications which are commercial. Not necessarily they will meet with the hospital's requirements. In such a situation, how do I create a solution which is used by hospital themselves or by the hospital's researchers? And these are the most commonly questions which are asked. Also, as you can see, the biggest challenge with AI is integrating AI into the hospital because hospital always have PACS, the picture archiving communication systems, and every hospital has different PACS. So the question is how do I integrate it into the radiology workflow is a very important question which is asked. And then few of them which I already covered. So all these questions can be actually looked into in terms of solutions in these 6 points which I have mentioned on the right side of the screen, which typically are the model decay and drift analysis, the fairness and explainability analysis for the AI, the model perceptibility, the trust score around the AI models, orchestration of AI, and creating activated data. And all of this is now possible in terms of an entire module or as a product. The concept of responsible AI was born because, as you can see, there's a lot of mistrust or less trust with AI. Radiologists or imaging physicians may feel a little uncomfortable using AI. And when we check for the outcomes may not be always objective. The role of responsible AI is to monitor the AI, is to look for outcomes in a much more objective way, in a much more scientific way. So it could have multiple repercussions. Repercussions in the sense that this information can be used by model developers to custom tune the AI model to the hospital's requirement. This information can be used for research. This research or this information can also be used for further automation in the workflows. So let's start with these concepts. How does someone identify model decay and drift? And what is this concept of model decay? Model decay basically means that the AI, which was working accurately for a certain period of time, has suddenly dropped in its performance. And that's model decay in a very simple manner. Similarly, there could be other concepts. And this is the concept drift and the prior probability drift. To explain this, the concept drift is an important situation where the outputs of the model, there is a change in interpretation of the outputs. For example, let's say the way tuberculosis is detected or diagnosed, the presence of pleural effusion and pleural thickening, whether that should be considered or not, and so on and so forth. And then there is something called as a prior probability drift. For example, an AI model which has been created for a chest X-ray, for ICU patients or for a public health screening situation is now deployed in an ICU setting. So these are called as prior probability shift. So every AI model has to be used in a particular situation. Identifying that becomes a critical point. The second point is about the fairness and the bias of the AI model. And here I have 3 examples to show how do we actually check for these. Here you can see that the AI model for a certain condition, let's say for a CT or a MR or let's say X-ray in this case, a simple, is not performing to the best of its ability for a certain race. Similarly, another example which shows that across age groups, the model is not consistently performing. For example, in this case, patients above the age of 60 are showing a significant high proportions of false negatives. Now, how can we get this information in a subjective manner? It is almost impossible. It can only be possible when we start tracking the radiology reports or any other clinical information and match it to the AI's performance, then you'll start getting this information in real time. Another example of a fairness and a bias review is this particular example where the same AI model, which is deployed in the hospital, which has multiple different type of X-ray scanners, is working well for scanner A and B, but for scanner C, its performance has significantly degraded. So as you can see, these are 3 different examples in which fairness and bias can present in AI model's performance. The third key point or one of the challenges while deploying AI is about the explainability of AI. How do you explain the AI output? How do you know where the AI see and you see both of them are a match? And to this, there are multiple different solutions, and they are shown in the case of these bounding boxes, or the heat maps, or the outline views, or the threshold score. So nowadays, there are multiple options available which show these different outcomes or the outputs which can be used by radiologists or imaging experts to know where exactly the AI feels is the problem. Coming to this information, now we have so much different sets of information. How do we use this information? We use this information by actually getting this information on a dashboard. So you can check for the sensitivity, the specificity of the AI models, the total scans reported positive, the total scans reported negative, the overall summary, and also the scans which were incorrectly classified. Using this information, you can see that every particular dot which is shown on this scatter plot is actually belongs to a particular patient, a data point, where you can easily compare the radiologist report or the pathology report, whatever is available, to the final output given by the AI. And using this, you can change the threshold and see how it impacts your performance, how it changes the hospital's performance in terms of the ROIs, in terms of the turnaround scan, time of the scan, or also in terms of the false positive and false negative, because this also carries a huge impact. Coming to the few points in terms of model perceptibility. So why we are doing all this thing is because we want to do real-time tracking of AI. Real-time tracking means making this information available on a dashboard to the hospital administrator, to the AI champions, that there is a problem and we have identified a problem and the problem exists at this particular level, and immediately ensuring from that particular study onwards on the work list, you are actually reviewing the AI output with a question mark, whether this output is really a real output or there is some questions around it. And to do that, we have this feature called the instability alert. That means the moment you see that there is a decay or there is a drift, or there's a wide gap in between the radiologist report and the AI output, you're going to get on your work list a feature or a system or a way to identify that there is a problem. It can also result in what we call as the incidence investigation, which can help you do a root cause analysis why the AI is not performing to the best of its ability for this particular situation. And then you can do and find whether there's a bias or something else. And also allows you to do what we call as performance monitoring. Thus, we come to the important point and then one more important concept, which is about orchestrating AI. As I said, there are more than 50 or 100 different solutions which are there in the market, which are approved by some regulatory agency or other, either US FDA or the CE mark. And these different solutions are waiting to come into your clinical workflows, into your radiology or pathology workflows. Now, when these solutions are going to come into your workflow, unless you don't automate the process of the studies directly going to that particular AI model, it is just going to create much more new bottlenecks. And for that, there is now a new tool called as the AI orchestrator. The role of the orchestrator is basically to send the particular scan to the particular AI model in a very seamless manner. Just to give you an example, for a CT scan of the chest, there could be 3 different models and there could be 3 different vendors. There could be a model which can work only on the high resolution CT of the chest to detect lung nodules. For that we need to identify it's a high resolution CT of the chest, and this is for the lung nodule evaluation, or it's a low dose CT. Similarly, there could be a model which works for pulmonary embolism, which typically works on contrast enhanced CT. And we need to understand that model is licensed for that hospital, it's available, and for this particular type of scan needs to go to this particular CT model. And it needs to go instantaneously because it's a medical emergency. So orchestrating these different AI solutions means that now there is a new tool which will be required in the hospitals, and that is called as the AI orchestrator. Using orchestrator, you can now do sophisticated protocols and enable administrators to define custom protocols for defining and sending cases, allows the users to focus on model capabilities instead of access restrictions, interface details, and whether they are deployed on-prem or on the cloud. Because a wrong study going to the wrong AI model has a lot of repercussions in terms of cost, because most of the CT models work on GPUs. And in case a wrong study, because of some wrong information on the metadata, has gone for a GPU processing in the cloud or even on premise, it's a huge cost to the organization. And that is going to change when you put in an orchestration engine. Finally, inference rules allows users for a pay-per-use model rather than pay-per-scan model by invoking a model only when it is needed. So you don't have to use that model for all the CT scans. It can only go to those subsets of CT scan which are low-dose CTs, or CT brains which are plain CT brains for stroke assessment. So all these custom tools can be invoked when you have an orchestration engine. Coming to the point for researchers, as we are a lot of researchers here because it's a university hospital, and many of the researchers in every department want to create their own AI tools because they clearly understand that they have a very particular use case and they would like to use it or deploy it in the real world within their own hospital. And how is that possible? It is possible again because of responsible AI. You could use this information to automatically annotate the scans, label the scans using what we call as tag extraction. So every radiology report which is getting generated by the radiologist or a pathology or something similar can be for other branches of medicine as well. You can extract the tags, create new labels, store it along with the image, and this can then be downloaded onto your own hospitals in an anonymized manner. So this can be used for creating your own AI models. So this is what we call as activating data. Data which has been lying in silos can now be activated using this tool. Finally, the last slide probably. is about the feedback loop and tag extraction. So how do we actually use this information? One question is, you have AI, you have radiology reports. How do you match that there is and see if there is a gap or not? The system what we deploy at the backend is explained in this diagram, where when the radiologist reports the scan, we capture the reports which have been done by the radiologist as text reports. We are also using smart reporting tools to capture this information. This report, which is text, is then passed through an NLP engine. And from this, we actually get the AI performance metrics. Similarly, whenever the radiologists have used any smart reporting tools, we are getting quantitative data and feedback, which also goes to the AI performance metrics calculation. Ultimately, this comes on a dashboard in real time in terms of the fairness review, in terms of the model decay and the perceptibility. And this feedback is then can also be given to model developers so that they can enhance the model further for the hospital's requirement. So this is typically how the responsible AI workflow works and makes it easier. So this is how we solve this major issue of building trust between radiologist and AI. This is how we solve the issue of measuring the impact of return on investment about buying costly products for assessment or using in the hospital. All this gets answered using responsible AI. We believe in the future, as AI is getting more omnipresent in hospital ecosystems, it's extremely critical to monitor the AI. And it is not going to be a choice, but it will be a requirement. We clearly see very recent developments in the European Union, where the European Union AI Act has come through, which makes monitoring of AI as equal or as important as deploying AI in your workflow. So every time you deploy, we'll need to have a tool to monitor the AI. These are just typically frequently asked questions about this tool. One is, does it work with any modality? Yes, it can work across modalities because it's vendor neutral. It works for radiology, it works for pathology, it could work for any tool. It requires two information. One is the report, which is the ground truth, which could be a lab report or any other report, and then the original data set on which you are comparing the AI. The second is it vendor neutral? So I have answered that question. The third question is this real time? Yes. There is no point of deploying a responsible AI module if the information is available after a few weeks, days, or even minutes. It has to be real time, because based on that, you are going to get alerted. The physician is going to get alerted whether they need to trust the AI from the next patient onwards. And that's why this is completely real time. What does AI use as ground truth? So I already explained radiology reports, pathology reports, all these are the ground truths which could be used by the AI. And I also told or discussed how do we extract the data from this. So this was a very short presentation. Just wanted to sensitize about this new tools which are coming and how this can be independent tools to monitor and how this can also be important tools to do research at a university setting. Thank you for your time and thank you for patient listening.